You okay?
Yeah.
Got it? Okay, perfect. Well, thanks, Kylie. Kylie's been quite persistent in trying to get me out for a talk. I'm going to try to stand in front of the camera. I do wander around. But this is a quite the interesting talk, the Gosselin Gold Zone. And it's really the second time I've been able to give this talk in public. The first time was in 2019 up in the Timmins area. And since then, we've had a maiden resource on Gosselin. So I've updated the talk a little bit to include that. So that'll be good near the end. And I titled the talk "The Road to the Discovery" because it was a bit of a road, a bit of a journey for our exploration team at IAMGOLD to get to the final stage, and that was the discovery of the Gosselin Gold Zone. And we made a lot of little discoveries along the way to Gosselin. And I'm going to try to touch on those throughout the talk because they were very important. They're lessons that we learned along the way that really got us to the ultimate goal of discovery. And then I'm going to end really with the talk with some arm waving around and really general discussion stuff, the stuff geologists like to argue about. That's how I'm going to end the talk, and it's really our path forward from discovery and what's more to be found at Côté and all in the Chester Intrusive Complex. Okay, just a cautionary statement. I'm going to wave my arms around a lot. And I do have some resource information, so technical information or qualified persons. Everything I have in here is referenced, so if you want to go look at our press releases, there's references on the slides that you can go and look in more detail. So just a little bit about IAMGOLD as a company and our operational overview. We are a mid-tier gold producer. We do have production from two mines. We have the open pit Essakane mine in Burkina Faso, West Africa. And we have our underground mine at Westwood in Quebec. Stats are all up there. 2022 production numbers, along with our 2023 guidance. And of course, Côté gold deposit that is currently under construction. You can see I have the Côté gold shirt on today, and I do get a lot of questions about Côté Gold and the construction that's going on there. The fabulous project that's being built currently. I don't have a lot of answers for a lot of the questions I receive. I'm on the exploration side of things. I can talk a little bit about exploration, which I typically don't unless it's been press released anyways. But in terms of the construction at Côté, I pretty much give a similar answer, and that's really just go to our website. A lot of useful information there. They have some beautiful drone shots of the project being built. We have our presentations about Côté, our quarterly releases and our quarterly presentations are there. I think the other day I was asked what size of balls we use in the mill. I'm sorry. Yeah, that might not even be on the website, but I get a lot of questions about Côté. Okay, so I'm going to start the talk off at a regional scale just to put us in perspective of the Abitibi. I'm going to work our way down to deposit scale, and I'm going to really even get down to the vein size scale. There's no thin sections, so don't start creeping towards the door there. I'm going to start off big and work our way down and then come back to sort of the district scale. So where are we? Well, here's the Abitibi. We've got the Cadillac Larder Lake break coming in through Matachewan here. Porcupine Duster Deformation Zone to the north.
Southeast end of the mines where they are here. Going on this lake. Stop.
Perfect. Okay, so the red box. So Abitibi Belt, 260 million ounces and growing. And I'm proud to state that our exploration team is really part of this growing of the Abitibi. As we get in closer, town of Gogama sits here, Timmins, Shining Tree. We're in this little square here of the Swayze Greenstone Belt of the Western Abitibi. Long time ago, I worked at Young Davidson, probably late 2000s. Even then, the Swayze Greenstone Belt, I heard of the poorly endowed Greenstone Belt of the Swayze, or the poor man's belt of the Swayze. And I'm sure that that narrative existed long before it even got to my ears. I think by the end of this talk, I think that narrative, and you'd probably agree with me, is changing or has changed, is no longer should be referred to as the poor man's belt. So we're going to zoom right in on IAMGOLD's mineral claims. This is our mineral package that we have in the Swayze Greenstone Belt. Over 500 square kilometers spanning 17 townships. On this property, we have numerous gold showings, cyanite porphyry hosted bulk tonnage showings. We have shear and alteration zone at lithological contacts, intrusion related breccia type deposits, and favorable structural traps, lithological controls, and favorable hosts to contact zones. When IAMGOLD acquired the Côté district from Trelawney in 2012, the exploration team was up there in 2012, 2013, 14, right up until now, and they've been scratching really the surface of numerous showings throughout the belt here and throughout our land holdings. And I'm going to come back some of those little areas that they were scratching around on. But right now we're going to zoom right into the Chester, and this is where the bulk of the talk is going to be centered around the Côté deposit. This black outline here is the mine lease perimeter of the Côté project. So now we're in the Chester intrusive complex made up of tonalite and those diorite lenses in this blue color here. And then the really faded blue is lakes. So the mine lease perimeter, we have the Côté deposit, and we have a number of other zones around Côté, which I'll touch on throughout the talk. We're going to really start our journey into the Gosselin discovery in 2017. We were the exploration team on site at the time. Not much else was going on except us scratching little surfaces around and different exploration projects around our belt. And we were asked to do a 40,000 meter drill program on the Côté deposit. We had 6 drills eventually turning on Côté, and we were also doing some condemnation drilling for future infrastructure related to Côté. At the same time that we were asked to do that 40,000 meter drill program, we were also tasked with developing a geological model for Côté. One didn't exist at the time, and if it did exist, it was not a very cohesive geological model. So what we wanted to do was put a really solid, cohesive geological model on Côté. When I first approached the idea of putting a model on Côté, I was told that it couldn't be done. Côté could not be modeled. It was too complex, it was too complicated, you can't do it. For those of you I've worked with, you know, I think I'm stubborn a little bit and maybe have a bit of an ego and be like, okay, you know, it can't be done. Give me the database, I'll give it a shot. You know, I'll come back and I'll have a model, at least some sort of model or geological model for the Côté deposit. I did get my hands on the geological database of Côté. I took it away for about a week, and I came back, and I wasn't as confident as I was when I left. I was kind of kicking the dirt, be like, okay, you were right. It can't be modeled. And the reason why Côté could not be modeled was not because it was too complicated. It's because the geological database and that column you used to model for geology was in rough shape, I'll put it kindly. There were over 200 different lithologies within the database. Some of the lithology codes weren't even rock types that any geologist would recognize. I think the one I really remember is a code called ALT. And I asked the geologist who had been there longer than I, what's ALT litho? And it was alternating rock types of different lithologies. Wow. So that was an interesting one. And really that referred to the breccia. So we rolled up our sleeves and we tried to consolidate the two under different rock types logged by at least 27 different geologists. We tried to come up with a common legend, tried to combine what we could. But in the end, the suggestion came from the exploration team that we really just need to relog Cote. Now, that's not a small ask, really. Cote consists of 300 kilometers worth of drill core. But we did have a member of our team that, as far as I remember, actually volunteered to relog Cote, and that was Laura Katz. She was a member of our exploration team, and she had just finished her PhD on Cote. So she was, at least how I remember it, eager, because I don't know if anybody else was, but we were able to, or she was able to relog the 300,000 meters of Cote via photo. And even the photos that were blurry and were off-centered, we had our Cortex go down, pull that core, take some more photos. And Laura was able to, I think it took her 3 to 4 months to relog the Cote deposit, which is a pretty spectacular feat. I don't think I could have done it. Definitely not. But in the end, what we had was a model, and it was logged by a single geologist. So a very consistent geological model. And we have entire presentations on how Cote was relogged. We wanted to do it so there was limited bias. So Cote was drilled in section. As Laura relogged it, we treated every drill hole as independent. So she didn't have a section on screen. She didn't log this hole, then go to this one and couldn't tell what this was and look at this geology and try to match them. Everything was done independently. So it was done in sort of the most unbiased way we could come up with it. And in the end, it produced a beautiful geological database logged by a single geologist. After she had done that, she gave me the database and the model just kind of made itself. It kind of fell into place, and we ended up with an excellent geological model for Cote. So what did we do with that model? Well, we used it as a guide to help us explore the Chester intrusive complex. We're pretty lucky as an exploration team to actually have a model to work off of. Typically, if you're working an exploration or a greenfield site, you reference the closest known deposit and say it kind of looks similar to this, and but here we are exploring in the Chester, and we have a beautiful geology model to reference. So that's what we did. We used Cote as a reference model. It confirmed that Cote is centered on a diorite hydrothermal breccia body, which is the main control for the gold mineralization at Cote. And additional modeling confirmed throughout the Chester here that the gold mineralization is strongly structurally controlled. So just a slide on the resources and reserves quickly here. So IAMGOLD acquired Trelawney. The gold or the orange bars here are measured indicated resources in 100% basis. In 2012, a lot of the resources were sitting in the inferred category, and IAMGOLD was able to get them into the measured indicated category. And as we worked through the years up to the feasibility study, we ended up with more in the indicated measured, proven probable, and less in the reserves. It just shows the progression that IAMGOLD did with Cote in terms of the resource. And then 30% sold to Sumitomo Mining Metals here in 2017. So now this is just a little movie, and it really just shows the construction after the relog had happened at Cote and in the geological model that was constructed by our team. So again, tonalite, diorite in the Chester intrusive complex. We have metachelon dikes cutting through. This is the breccia body, our 300,000 meters of drill core going through. There's some diorite lenses that are cutting through the intrusive complex here in the tonalite. We're going to start looking east now within the breccia body. And the breccia is really composed of a magmatic and a hydrothermal breccia. The magmatic breccia sits up here to the south in higher elevation, and the hydrothermal breccia down here to the north. I was able to take the gold database and smush it together with the geological database, and it's just the contours of the gold here within the breccia body. And as you could see, a sharp lithological contact between the two breccias. When you actually look at the gold grades, you don't see any difference. The gold between the two breccias is very, very consistent. I'm going to pause the movie here because this was one thing that came out of the geology and mineralization model at Côté that really caught the interest of our exploration team. And it's not really a surprise, but it's just nice seeing it in a 3D form like this. That when the breccia intruded into the Chester intrusive complex, it brought in the gold with it, but it also created this gold halo within the rocks it intruded in. This is the diorite right now, and it's just contoured with gold grades. And you can see the closer that lithology is to the intrusive breccia, the more altered it is and the more gold it has. So as an exploration geologist, if we were searching for one of these breccia bodies and this entire thing was covered with overburden and we came in and we drilled a hole and we totally missed the breccia body, but we hit alteration over significant width with low-grade gold, what this model is telling us is that we could be in this alteration or this gold halo of a breccia system. So to keep going. So we just come back to the Côté geology model here in the end. Now I'm going to jump back a year in time here. So we went from 2016 and we're going back to 2016 or 2017 to 2016. Côté sits over here just off the map. This is Three Duck Lake here. And this is one of those little surfaces that the exploration team was scratching away at throughout our land package. Excuse me. It was called the Gosselin showing. And what it was visible gold had been found along the shore here of Three Duck Lake back in the 30s by a prospector named Alfred Gosselin. In 2016, the IAMGOLD team was looking at this area and we had done some mechanical stripping here of high-grade gold veins. We had pulled back the overburden and we were mapping, and we had done 2 short drill holes under this outcrop. And this outcrop still exists today and you can visit it. What IAMGOLD was finding, where they're finding, they're still finding these little veins, sporadic gold within them, but they're starting to see a little bit of alteration associated with these veins. They took a step back further in 2017 and took a deeper cut at this outcrop. And what they found within this hole, even though it was all tonalite, is that over 10 meters, we had alteration, sericite silica alteration with some gold mineralization associated with it. Now, another movie. So again, Côté Gold, really harping on this alteration and gold halo around the breccia body. You just spin us around here. And then we're going to jump over 1.5 kilometers to the east. All these little dots are surface samples throughout our entire land package that the guys have been mapping and taking samples of. And there are those high-grade veins they talked about on the shore of Three Duck. These were the short little initial holes IAMGOLD had drilled under this outcrop, and then this is our step back hole in 2017. As I mentioned, about 10 meters of alteration and gold associated with that drill hole. So what that was telling us in 2017, based on the Côté model, is that we have alteration, even though it's only over 10 meters with gold associated, we potentially could be in a halo of a breccia system. At least that's the way the exploration team likes to spin it to get an additional drill hole. What you see down the drill holes here are vein measurements. All our exploration holes on Côté are orientated core. So we had alteration in this hole. and we wanted to find more of it. So how do you do that? How do you vector towards more alteration or potential breccia body? Well, we looked at the veins, and we had orientation on all these veins, and the veins were telling us to go up to the northwest. So we stepped up here with 1704, and we drilled that hole. It actually ended right here. This was an addition later. That hole hit 90 meters of alteration with gold over that width. So we're getting hotter, really. We're extending that alteration zone. Again, looking at the veins within that alteration zone, we stepped up to the northwest again with 1705. And as we were drilling 1705, the alteration was picking up in intensity as we drilled deeper. And then we tagged into a hydrothermal breccia body at the bottom of 1705. Now, we are quite excited as an exploration department. First of all, our little alteration halo theory from Côté had worked over here on the shore of Three Duck Lake. By following the veins that we had measured within these drill holes, we were able to find that breccia, hydrothermal breccia, the thing we're hunting for. So we were quite excited. This core actually looks quite amazing, chock full of sulfides. We're, high-fiving each other, pretty happy. Management was congratulating us, but they're sometimes the unemotional ones and said, well, that's great, but it's a little deep for an open pit. And yeah, they're right. The average grade of hydrothermal breccia is about 1 gram gold, and we're down, I don't have a scale on there, but a few hundred meters. So we are a little deep for an open pit, but just to tag in the hydrothermal breccia outside the Côté deposit was a great feat for us. So how do we get shallower? What we did was we looked at the veins within that hydrothermal breccia body, and they led us here with the alteration zone. So maybe they can lead us to something else. Let's see if the movie comes back. Yeah, there we go. A little stereo net. So what the veins were telling us is that go up this way or go down that way to the east. So what we did is we went west. We wanted to be more shallow. So we walked our drill along the shoreline of Three Duck Lake, and we drilled in the up dip direction, the way the veins were telling us in the hydrothermal breccia here. And we were able to tag into shallower hydrothermal breccia with at least 2 more holes and these were drilled in early 2018. There's our stereo net, and we were able to put a crude model on the hydrothermal breccia body there. And what we're discovering is that the veins sort of led us in the right direction. So what we did with this model here, it's just not a blob. What we did is we underpinned it with the structure of the veins that we're finding within the breccia. So you can see how elongated it is in some directions. It's actually, if we turned it on its side, it is coming up towards air under the lake here. It is trending in this direction. It's moving this way. So what we did is we checked in those different directions. And you see the stereo net on the background there. And we followed the different directions that the veins were telling us within that hydrothermal breccia body that we found under the lake. And the direction that I think we liked best, even though we did check them all, was the one that was pointing right back to the mothership here, right back to the Côté. And there's some breccia of Côté, hydrothermal breccia at depth. And we were trending in this direction back here. Again, this trend that we were finding within the veins, and only within the veins within this breccia, this was not a new trend on the property. This was a historic trend that had previously been identified, called the C zone. But it was nice that our recent data was actually matching close to the historic trend. So as we zoom in on the breccia body here, a very crude model yet again, but what it was showing is an alteration zone and a gold zone existed around our little hydrothermal breccia body here. Just a miniature version of what we were seeing at Côté. And as we zoom in even more, what we wanted to do was get right on top of this in 2019 and start drilling right under the lake. So in 2019, we did get out there, and we got out there in the winter time, and we made this ice road. And these are just planned drill holes from the ice road to get right on top of the hydrothermal breccia body. Not only the body, but also this golden alteration halo. So there I am standing out there, some geologists, and we're watching water move from the bottom of the ice to the top of the ice and then watching it freeze. There's our drill out there on the ice pads that we've made. And then we drilled a series of holes in 2019. A number of holes, platforms were made, and we're drilling away. We have press releases all for our 2018, 19, 20, 21, 22 drilling on Gosselin. So just to put it in schematic here and not movie mode, we started over here, drilling away. There's that 10 meters of the initial alteration that we hit, over a gram. We stepped out following the veins, got into 97 meters of alteration and low grade gold, stepped out again, and that's what we're calling our discovery hole of Gosselin, 345 meters, 0.68. And once you get into the hydrothermal breccia, we got 132 of over a gram. There's our little crude model based on 3 drill holes. And what we did is we stepped along and followed the veins from that model. So there's our stereo net. There's the trend. We did look up in this direction too. We extended that 04 hole. Didn't get much joy, but this is where we were getting. We stepped along the shoreline here of Three Duck Lake, and you can see our intervals and our composites of these holes. What we were trying to do is drill parallel to our plane here that the veins were pointing us back towards Cote. So we're just looking at that time of the veins within the hydrothermal breccia. So really, we only had 3 intersections into the breccia at this point, but we were drilling off the halo of that breccia body. What it was doing, it was trending up and back towards Cote. So again, stuff from 2019, we got right on top of it with our ice drilling, 342.5 meters of almost a gram gold, including 225 of 1.3. And at the time, this was our best hole of 412 meters of 1.28. We're able to put a bit of a rough geological model to Gosselin. And what it shows is a hydrothermal breccia body to the north and at depth. And to the south, we do have a diorite or a magmatic breccia. So it's almost a miniature version of the Cote breccia body. In between, there is a heavily altered zone we call tonalite 2. But it's just an area that's been heavily altered. We do have diorite breccia, as I mentioned, and the diorite lenses, and then a sea of tonalite all around. We actually took all the vein measurements within tonalite, diorite, and we incorporated that into our geological model. It was working for tracing the breccia, so we thought we'd incorporate within the other geology shapes and see if that would help us define and help us trace the diorite and the diorite breccia, the tonalite too, and it actually worked quite well. And again, the breccia body at Gosselin was showing this gold halo and alteration zone around it. And there's a piece of the breccia there. There's the breccia matrix. It's normally chock full of pyrite, chalcopyrite, and then there's blocks of tonalite and diorite from the surrounding rock. Now this was great. So we have Gosselin. The breccia body is under the lake here. It actually doesn't pop up anywhere along shore. This is just the projection from depth up. It was marching. We were marching our way down the shoreline here, drilling it off, marching our way back to Cote. These are 0.3 gram per ton grade shells that are just projected the surface of both Gosselin and Cote. And they were getting so close to touching. And we were walking our way down here, but something was getting in our way, and that was the Young Shannon zone. Now, when I first got the site, we didn't talk about Young Shannon. Young Shannon didn't have a very positive connotation on site. There's a historic shaft related to Young Shannon, and it was basically a high-grade system that nobody could do much with. Economically, it didn't work. and people really had tried. So what we had to do was we took a harder look at the Young Shannon system here as we marched our way back towards Cote with our Gosselin drilling. So what is Young Shannon? There's just a picture of underground. There's a nice vein at Young Shannon. So there was an incline shaft sunk in the mid to late 30s, 49 meters of development on the 30-meter level, 52 meters of development on the 57 level. Mining occurred in the 40s and then the late 70s. And there had been multiple diamond drilling campaigns from the 80s, 90s, early to mid 2000s. And to sum up Young Shannon, I just put a bunch of bullet points here. The gold occurs in veins and veinlets, stockwork zones. Visible gold is often observed. It's associated with moly, pyrite, chalcopyrite, sphalerite, and arsino. The gold-bearing shear zones often have silica flooding and sericite alteration. And this is the main one I want you to remember, if you remember anything from this slide, is that the gold structures pinched and swelled, and they did not exhibit consistency in stratigraphic location. So like I said, our veins were pointing us back this way. We really wanted this system to connect with Cote. We took a hard look at the Young Shannon area here, and we're going to look at a section through Young Shannon from C to D. There's just some of the historic drilling that we were able to compile. There's the underground workings. And we're going to look at this section of drill holes that was drilled here. So a very nice section that somebody had put together back in the 80s there. You can see there's the drill holes coming down. Now, I don't have a scale bar on here, but they're roughly 30 meters between collar from here to here to here to here, and then half that as you get closer to the lake. And this is what they were talking about the pinch and swell. You'd get nice gold intersections, and then they couldn't get them up from the very next line 30 meters away. Same with down here. This looks like a really nice hole, but they couldn't trace it up or down dip. So when our exploration team looked at this, well, we saw what everyone else saw. The zones, they're having a problem connecting. You think this guy would have been able to go down here, but this hole really puts a wet blanket on things. But it looks kind of weird. We had issues with it. Like, how can this happen geologically? Why aren't those zones connecting? So as I said, we're marching our way back here. We looked at multiple sections through Young Shannon, and here's another one we'll show on A to B. Same issue. Terrific hole here, 90, 181. Lots of gold zones throughout it. Half those zones maybe made it 37 meters to the next hole, and only 2 made it to a hole that was colored off the same spot, just up dip of this one. So again, these sections were confusing us. So what did we do? Well, we didn't try to remodel this. What we did is we went right back to the drill core. This core all existed on site. Our technicians actually had to cut paths to the cross piles because it was so overgrown. We got out there to the cross piles. The technicians were to rebox a lot of the core, the stuff we could, and we recovered quite a bit of core, and we brought it back to the core shack. Upon recovery of the core, what we noticed, significant pervasive alteration, sericite silica through the core. It was also noticed that large sections of the holes were unsampled. This hole looks terrific, but the only thing that was sampled in it are these zones. Everything between these zones was left unsampled. It was still whole core. So what did we do? We re-logged these holes. And what did we find when we sampled the entire hole? Well, there was gold throughout the entire hole. That pervasive alteration had gold in it. The entire hole averaged 128 meters of 1.12 grams per ton. Now, I give the old timers a lot of credit. For any of us that have worked in Ontario and we've been trumping through the bush up here in the Abitibi, I don't know how those guys found the trenches and the pits they did. I think they knew there might have been gold throughout this entire hole, but back in the 90s, the price of gold was so low. This is waste. The problem with young Shannon was that the story of high grade stacked veins persisted from year to year to year, and nobody bothered to question that story or that theory of the high grade veins. When we saw this, what we did was kind of like a smack of the forehead or the light bulb going off above you. Here you have the Cote deposit, a large tonnage, low grade deposit. Our recent discovery at Gosselin, turning into a large tonnage, low grade deposit. And between the two of them is a high grade stacked vein deposit. One of these things doesn't belong. And really, what the conclusion was is that young Shannon is no different than Cote or Gosselin. It just had the wrong story put on it. And you really just needed to go back to the core to prove that. You can see these holes here where those veins were brought through. That was all that was sampled in those holes when we pulled them out of the bush. So what we wanted to do was confirm this. This was a historic core. We had old maps that show where that casing was, but it was drilled on lake ice. So we went back and we twinned that hole. So not only did we confirm that, yes, gold mineralization is consistent through that hole, we're able to extend the gold mineralization to 390 meters vertical. Last sample actually ended in a gram gold. We had to get off the site. We're drilling on lake ice. You can only stay on a lake ice spot for so long as the ice erodes under you. It becomes unsafe. You got to move. But we could have kept that hole going for sure. So what did we do with young Shannon after this? Well, we went back and we grabbed as many of the historic holes as we could, and we resampled and relogged them. And you can see the intersections that we got out of some of the highlights here. This one here, right above the Gosselin breccia, the hole was only drilled 105 meters. It just came up short of that breccia body. But they had 0.86 grams over that entire length of the hole that was only partially sampled. So, young Shannon, we've sort of changed the narrative on young Shannon. It is not a high grade, narrow vein system. It's no different really than Gosselin or Cote. But what it was missing was the key ingredient in our model. It was missing the breccia. Is it part of the Gosselin breccia alteration gold halo, or does it have its own breccia system? As an exploration geologist at budget time, it's missing breccia. So we wanted some funding. We wanted to see if there was a breccia system contributing to this gold. I'd tried and I'd failed at trying to measure how far this halo would come off of breccia. I looked at Cote, I looked at Gosselin to see if there was a range. This still seemed like a stretch too far from the Gosselin breccia and from the Cote breccia. So this slide I made back in 2019 when I first put this talk together, saying missing breccia, and it was around budget time. Now, if you've been paying attention to our press releases, we had one in February of this year, and young Shannon sits right up above here. And we finally tagged into what we think might be the breccia system associated with the young Shannon gold mineralization. We're looking north and a longitudinal here. There's the Gosselin breccia zone that we've been able to define. And we're starting to get into intersections of breccia below our Gosselin resource pit. And you can see our nice intersections that we're getting within the breccia body. So again, from February 2nd, this was our press release of our 2022 drill holes. You can see on here, we do have a block model for Gosselin now that was released in October of 2021. And this is just a little snippet out of that press release. On a 100% basis, we're able to define 124.5 million tons of indicated resources of 0.84 grams per ton gold for 3.35 million ounces, and 72.9 million tons on the inferred resource of 0.73 grams for 1.7. So total contains about 5.1 million ounces on Gosselin. Now, if you're wondering, the Cote deposit next door measured indicated of 365.5 million tons of 0.87 for 10 million ounces. Inferred resources, 189.6 of 0.63 for another 3.8. all together, total contained, we're looking at around 19 million ounces. Gosselin was able to increase the mineral resources at Côté by 33% in the measured indicated resource and 45% in the total contained. So from that press release as well, you can see when you put a longitudinal up of the Côté deposit and it's block modeled and we're filtered at 0.3 grams per ton and greater next to Gosselin. You can see Gosselin has only been defined to half the depth of Côté. So we're still open. And if you saw back on the 2022 release, we're starting to get mineralization under this block model here. So we're not done at Gosselin by any stretch. And there's just an incline view of the two resource pits, Côté here and Gosselin up here. Now, I remember Al Smith, our district manager, was giving this presentation and had put the slide up. And I think someone from the crowd yelled, "Well, it's so obvious. How could you not see Gosselin there?" But Al wasn't giving the discovery talk. Everything I've talked through walked us how we found Gosselin, and it's really not that obvious. This slide makes it look easy, but it was not an obvious find by any stretch of the imagination. This property has been walked over since the 1930s, and nobody has able to define as the Gosselin zone. Now, in a global aspect, what's Gosselin look like? This was an article that came out in May of 2022. Gold in the initial resources hits a record high in 2021. And they looked at the top 10 initial gold resources over a 5-year span from 2017 to 2021. Gosselin came in 6th in the world. We're actually top 3 in 2021, 6th globally, against all these other deposits for total contained ounces. And again, we're only drilled at half the depth of the Côté resource. So again, from our 2022 press release, you can see these are the holes that are drilling deeper. And we have a new champ here of Gosselin out here on the island, 2022, Gos 22-105, 342.2 meters of 1.99 grams per ton, including a whopping 100 meters of just over 3 grams per ton gold. 450 meters away from that hole, you can see 313 meters of 1.3 grams per ton gold, including 75 meters of over 3.5 grams per ton. So we've started at Côté. We had an excellent model that was built off a relog. And combining the geology with the assays, we're able to identify that alteration halo at Côté. We then took that model and applied it throughout the Chester. And we thought we got onto something over on the east shore of Three Duck Lake here that led to the breccia body at Gosselin. We then used the veins at Gosselin and worked our way back and ran into Young Shannon. We call Young Shannon the rediscovery of Young Shannon, but now it is now combined with Gosselin. We call this whole area just the Gosselin zone. There's a lot of lessons that we learned along the way doing this work over the years. And it's really start with some quality data. If we didn't have a solid geological model that came from doing things right, of taking a lot of core and relogging it to get a proper data set and then using that to make a proper model, we wouldn't have identified that alteration halo. We might not have been as quick at finding Gosselin as we were. So how does all this tie into each other? Because we're not done. Gosselin's a discovery, but we'd like to find more. So we know we need breccia, okay? And we have our new breccia that's pointed at this arrow here that we've recently found. Breccia is the source of the gold within the Chester intrusive complex. I just threw up all the surface samples we've ever collected in the Chester here. The scale is not important. You just have to see if there's a little bigger than a little dot like this, there's gold associated with it. We threw up the gold halos around these breccia bodies and to see how everything sort of connects. And we know structures are important. throughout the Chester. At the time, doing vein measurements within our breccia, we had 355 measurements that was pointing us back towards Cote. Cote had slightly more, just over 5,000. We had a few down here at Clam. Didn't really have any breccia down here. But from all this data, we're able to produce something we called the yellow brick road or the structural corridor through the Chester. And as an exploration department, we hypothesized we have to be within these dotted black lines to find more breccia and potentially another deposit within the Chester. And I remember showing this to our team and everybody had questions. But our project geologist, Brian Tomchuk, said, well, we do have some geophysics we can throw up here too. There'd been IP surveys done almost right across this area. So we looked at the 50-meter depth slice of chargeability, and we threw this on here, and it really confused all of us, and it really still does to this day. This tonalite up here, there seems to be a band of chargeability through the tonalite diorite in the Chester. This tonalite down here is no different than the tonalite up here, but this stuff is chargeable and this is not. What's it mean? I don't know. What it shows is that the breccia bodies are occurring on the southern edge of this chargeability band through the Chester. Does it mean anything? I don't know. But it gives us a little bit more places that say maybe this corridor is the place we should be looking for breccia. Mind you, we are missing a good chunk of it down here. So why is Cote where it is and why is Gosselin where it is? And how can we find more? So we have our corridor that was defined back in 2019. Since that time, we've done an awful lot of work on Gosselin, and it's really an entire different presentation, and I didn't really touch too much on it. But we saw the power of the model that we were able to produce at Cote just from doing the geology properly and doing the mineralization and sort of mashing those two models together. We saw that halo. In the very early days of Gosselin, we knew, well, we hoped we were onto a new system, but we were a bit forward thinking in our ways. And we said, if we get onto a system like Cote, what do we want the Gosselin model to look like? Not only do we want to have a gold model, we want a litho model, but we also want an alteration model. We want a silica model. We want a sericite model. We want a structural model. This is the big model we want. And we want it all talking to each other. So if I'm asked, what's the gold concentration within a certain percentage of silica or sericite, or which veins respond in this direction to gold grades, we're able to filter our model and end up with a model that we can filter on any aspect or any combination or ratio of elements that we dream up. So what we did at the very early stages of Gosselin is that we said, this is the model we want. How do we get there? So it's the way we log and the way we collect data. So what we did is we created our own logging system. This is the way we need to collect data at Gosselin, and we created our own database structure. So every geologist on the team bought into that, being this is the model we're going to end up with. This is the way we need to collect data. Again, it's an entire presentation of the way we created our logging system, but it worked out quite well. So our Gosselin model is a combination of everything. We can now filter, we've got down to which veins are specific to the gold mineralization. What range of sericite and silica respond best to the gold. If it's too high a silica, we lose gold. If it's too low, it's not there. There's a nice sort of Goldilocks zone, and that's all coming from our database. So this is a very strong structural model, alteration model. So we're very confident enough, I didn't have to put a little question mark here on Gosselin, that we think there's a structure, a northeast structure coming up and an east-west structure coming across. Where those two structures meet is where we get the hydrothermal breccia body. So that's the control on the mineralization. I took these little diagrams from an economic geology review. It was really on elongated emplacements, but they work quite well for this. Cote, well, according to our little structural model here, it could be a bend, a dilation zone on why the breccia is where it is. And then I don't know what's going on at Clam, but it could be anything. We also have Jackrabbit up here. But since the question mark doesn't exist on our little intersection model, we're fairly confident in this model. So just like we took the original Cote model around the Chester, we now have model 2.0 here from Gosselin that we can take around the Chester. Let's take that model back to Cote. And maybe we made the similar mistake with this model that we made with the Young Shannon system, thinking it has to be complex. Maybe things are a little more simple than we first realized. Maybe things are a little more linear through the Chester than we first realized. We're fairly confident in our intersection here. There is evidence within Cote of east-west structures running through the Cote deposit. There's alteration trends trending east-west. You can see in the geology map here, east-west structures, and there's east-west structures in gold throughout the Chester. So what if we just take this model and apply it throughout? If we track this line up here, it actually runs into historic pits of the Jackrabbit area. Are there east-west structures there that we can go and explore now? This is sort of the latest thinking that we have in the Chester, that maybe things are a little more linear and simple. Maybe not this simple, but this is where we're sort of looking. This area has been underexplored or not explored at all. It's covered under overburden. Jackrabbit, like I said, is just historic pits that really need a hard look at. Again, a lot of dotted lines and a lot of question marks, but this is where we're at as an exploration team currently. So I've talked enough, but a big thanks to our current exploration team. We're not a very large group, but I find we're a pretty powerful group. And I may be biased, but I think we probably have the best exploration team out there. Headed up by Al Smith up here, our district manager, myself, Brian, Caitlin, Maggie, Mark. We got Beatrice in the crowd here today. And Justin, he didn't have a picture without a fish in it. So that's the best we could do there. So thank you.